All right, welcome. Ever wondered how we actually tell a computer what to do? How we get from an idea to a working program? Well, over the next few minutes, we're going to crack the code, literally, by looking at the absolute basics of programming. Let's jump right in.
So, check this out. This is where we're headed. This little window is our final product. It's a program that took a number, 20, and used it to calculate the area of a circle. Pretty simple, right? But it brings up the biggest question of all. How do we actually write down the instructions, the code, to make the computer do this for us?
The best way to think about a program is, well, it's like a recipe. The computer is your chef, and it follows your instructions, your code exactly as you write them. It can't guess. It does precisely what you tell it to do step by step. So let's look at the most important line in our recipe.
Now, this line of code, it probably looks a lot like simple math, right? And, well, it is. But here's the thing about computers. They're incredibly fast, but you have to tell them everything. Right now, it has no clue what radius or area even are. Before we can do any math, we have to actually define those words and tell the computer where it's going to store these numbers.
And that brings us to our first huge concept. If our program is going to work with values like radius and area, it needs a way to remember them. To make this happen, it uses two key things: variables and data types.
Okay, so a variable. The absolute best way to think about it is to just picture a labeled box. That's all it is. It's just a little spot in the computer's memory that we give a name to so we can stick some information inside and then find it again whenever we need it.
So, how do we make one of these boxes? We write a line of code just like this. This is called a declaration. All we're doing is telling the computer, hey, I need a new box, a place to store something, and I'm going to label it radius. And see that word double at the beginning? We'll circle back to that in a second because it's really important.
All right, so we've got our empty box with a radius label on it. Now we got to put something inside it. That equal sign in programming, it doesn't mean is equal to. It's called the assignment operator. It means take the value on the right and put it inside the box on the left. So we're putting the number 20 into our radius box.
Okay, so this brings up a really good question. Can we just stuff anything into any box? What happens if we try to put a word into a box that's expecting a number, or a decimal into a box that's only for whole numbers? Turns out the computer needs to know what kind of information to expect.
And that is exactly what a data type is for. Before we even create the box, the data type tells the computer what kind of box to make. You wouldn't put soup in a shoebox, right? Same idea here. You got to use the right kind of container for the right kind of information.
So let's break down the most common ones you'll see. If you need to count something, whole numbers with no fractions, you're going to use an int, which is short for integer. But for anything with a decimal point, like money or the area of our circle, you're going to need a double. That's why we use it for our radius. And if you just need to store a single letter or symbol, you use a char.
You might be thinking, why all the different types? Why not just use the biggest, most flexible box for everything? And the answer is all about being efficient. Using a giant shipping container to mail a letter would be a huge waste of space, right? It's the same thing here. Using the right size data type saves memory and helps your program run faster. It's all about using the right tool for the job.
All right, we've got our ingredients, and we've stored them in the right kind of boxes. Now it's time for the fun part, actually doing something with them. And that's where operators come in. Think of these as the action words of programming. They let us do all the calculations.
Now, most of these are going to look super familiar. You've got your plus, minus, multiplication, which is that little asterisk, and division. But I want you to look at that last one, the percent sign. This thing is kind of like a programmer's secret weapon. It's called the remainder operator, and it is way more useful than it looks.
Let me show you why this is so cool with a real-world problem. Imagine it's Saturday, and you need to figure out what day of the week it's going to be 10 days from now. Sure, you could count it out on a calendar, or you could let the remainder operator do all the hard work for you.
Okay, so check this out. Let's pretend Saturday is day 6 of the week. We add 10 days to that, which gets us to 16. And here's the magic trick. We ask the computer, what's the remainder of 16 divided by 7? Well, 7 goes into 16 2 times for 2 full weeks, and what's left over, the remainder, is 2. So that tells us we're 2 days into the next week. Day 2 is Tuesday. It's absolutely perfect for any problem that works in a cycle.
Okay, so we've got the basic recipe down. We can store numbers, and we can do math. But our program still has a pretty big limitation. Right now, it's just a static recipe. To turn it from a simple recipe into a really useful tool, we need to make it dynamic. We need to let the user provide their own ingredients.
See, the problem is, right now our program is hard-coded. That's a fancy way of saying the number 20 is stuck right there in the code. It'll only ever work for a radius of 20. But what if you want to find the area for a radius of 5 or 500? To make this program truly useful, we need a way to ask the user to type in any number they want.
And there are basically two main ways we can do this. First, there's the old school way, console input. You're just typing directly into a simple text window. It's basic, but it gets the job done. Then there's the much more modern way, a GUI, or graphical user interface. Think pop-up windows, buttons, text boxes, all the stuff you're used to interacting with every day.
And this picture says it all, right? On the left, you've got that super simple direct console. It works, but it's not very pretty. And on the right, that much friendlier graphical pop-up. Both of them can get the input from the user. They just provide a totally different experience.
All right, we've covered a lot of ground: variables, data types, and operators. Now it's time for the payoff. Let's put all these little building blocks together and see how they can solve a really practical, everyday problem.
Check this out. You ever wonder how a vending machine or a self-checkout knows exactly what change to give you? It's using this exact logic. Take 1156. First, we convert it to 1156 cents to get rid of the decimal. Then, we use simple division. 1156 divided by 100 gives us 11. That's our $11. And now our secret weapon, the remainder operator. 1156% 100 tells us what's left over, 56 cents. And you just keep repeating that same pattern, division to find out how many coins, and remainder to see what's left over for the next coin. It's a perfect combination of everything we just learned.
And believe it or not, that's really it. Those three things: storing information in variables, doing math with operators, and getting input from a user. Those are the absolute fundamental building blocks you need to start telling a computer precisely what you want it to do. So there you have it. You now have the basic toolkit of a programmer. You know how to store information, you know how to perform calculations, and you know how to make your programs interactive. The only real question left is, what problem are you going to solve first?